Hello, Concord Junior High students. This is Mr. Rock with a math video. In this video, you will learn how to solve inequalities. Inequalities. When trying to find a maximum or minimum of a quantity, inequalities are used. The symbols are greater than or equal to, less than, and less than or equal to. Examples: 5x is greater than 15, and 8x plus 5 is less than 2x minus 1. Inequalities are solved with opposites, the same as equations, except when multiplying or dividing by a negative number. When that happens, reverse the direction of the inequality. So for example, negative 9x is greater than 18. The opposite of multiplying by negative 9 is to divide both sides by negative 9. Negative 9 divided by negative 9 is just 1. 1 times x is x. 18 divided by negative 9 is negative 2. But notice the inequality was greater than after dividing both sides by negative 9. It changes to less than. Okay, it says solve for W. Reduce any fractions to lowest terms. Don't round your answer. And don't use mixed fractions. This problem comes from Khan Academy. So let's write this down. We have 53W plus 13 is less than 56W plus 16. Probably a lot of you are going to solve this by subtracting 13 first. So we get 53W, this much is 0, is less than 56W plus 3 minus 56W from both sides. And we get negative 3W is less than 3. Divide both sides by negative 3. Remember to switch the direction since we're dividing by a negative. So it's greater than negative 1. This is your answer. And something else to point out about inequalities is that most often they have an infinite number of solutions. I forgot to mention that earlier. So W represents any number that's greater than negative 1. For example, 0, 1, 2, 3. Any positive number would work. But numbers like negative 10 or negative 11, those are not solutions because those numbers are smaller than negative 1. All right, here's another example. This time we're solving for t. Again, the directions are the same. Reduce any fractions to lowest terms. Don't round your answer. And don't use mixed fractions. Fine, I can follow those directions. We have 12t minus 2 is less than negative 5t plus 36. I think this time I'm going to add 5t to both sides first. As long as I do the same operation, as long as I add or subtract the same amount to both sides, that keeps it equal, so it's legal. So that's 17t minus 2 is less than 36. Add 2 to both sides. I get 17t, that much is 0, is less than 38. Divide both sides by 17, and I get t is less than 38 over 17. Notice that I did not reverse the direction of the inequality. The reason I didn't is because I never multiplied or divided by a negative number. All right, here's a word problem. Anand needs to hire a plumber. He's considering a plumber that charges an initial fee of $65, along with an hourly rate of $28. The plumber only charges for a whole number of hours. Arnold would like to spend no more than $250 and wonders how many hours of work he can find. Let H represent the whole number of hours that the plumber works. Which inequality describes this scenario? Well, I'm going to try to figure out the answer myself. I think the initial fee is $65, right? And an hourly rate of $28 per hour. And this has to be less than or equal to $250. So you can kind of see why we use inequalities here. Inequalities allow us to figure out how many hours, the maximum number of hours this plumber can work. So here's my inequality. Which answer choice doesn't match? Ooh, I think it matches this one right here. It matches that choice. So now let's solve this inequality. So minus 65. I get 28h is less than or equal to 185, and then divide both sides by 28. This time I think we're going to want to leave our answer as a decimal. So H equals around 6.6 hours. So the question is, what is the largest whole number of hours that Anand can afford? Anand can afford to pay the plumber 6 hours. So that's the maximum number of hours that he can pay for. All right, here's another example. Sergey runs a bakery. He needs at least 175 kilograms of flour in total to complete the holiday orders he's received. He only has 34 kilograms of flour, so he needs to buy more. The flour he likes comes in bags that each contain 23 kilograms of flour. He wants to buy the smallest number of bags as possible and get the amount of flour that he needs. Let F represent the number of bags of flour that Sergey buys. All right, well, Sergey already has 34 kilograms of flour. And he's going to buy some bags of flour. And each bag of flour contains 23 kilograms of flour. He needs at least 175 kilograms of flour. So this amount has to be greater than or equal to 175 kilograms. So let's see which answer choice is that. I think it's this one right here. All right, so now let's see how many bags of flour he needs to buy. So minus 34, we get 23F. It's greater than or equal to 141. Divide both sides by 23. So F equals 2.81. So in order for Sergi to have enough flour for his bakery, he needs to order 3 bags of flour. That's the minimum number of bags that he can order, is 3. So again, inequalities help us find a minimum or maximum amount. Okay, on the screen is what you call a compound inequality. That compound means more than one. So here's the first half of the inequality. 4x minus 4 is less than 8. And here is the second half of the inequality. 9x plus 5 is greater than 23. So the first thing we're going to do is we're going to solve each inequality separately. So I have 4x minus 4 is less than 8. And I have 9x plus 5 is greater than 23. All right, so I can solve these. Add 4, 4x is less than 12, divide by 4, divide by 4. X is less than 3. On the right-hand side, minus 5, minus 5. I get 9x is greater than 18. Divide by 9, divide by 9. X is greater than 2. So these are the solutions that I get. The only solutions that count are the solutions that are in both answers. So I can only count x values that are smaller than 3, and I can only count x values that are greater than 2. So the answer choice here is going to be answer choice A. So for example, let's pick a number in answer choice A. Let's say 2.5. That's bigger than 2 and smaller than 3. Let's see. Is 2.5 less than 3? Yep. Is 2.5 greater than 2? Yep. So when you have an and, your solutions have to work in both inequalities. If they work in one inequality, that's not enough. They got to work in both. And this is called a compound inequality. Okay, this is another compound inequality. And the reason it's compound is because there's more than one inequality. There's one here on the left-hand side. 2x plus 3 is greater than or equal to 7. There's one on the right-hand side. 2x plus 9 is greater than 11. And notice that we have the word or there, or. Okay, so let's solve each inequality. So I have 2x plus 3 is greater than or equal to 7. And I have 2x plus 9 is greater than 11. So let's solve the one on the left first. So minus 3, 2x is greater than or equal to 4. Divide by 2, divide by 2. X is greater than or equal to 2. On the right-hand side, we're going to minus 9. We get 2x is greater than 2. Divide by 2. And I get x is greater than 1. So when we use the word or, that means that we pick a solution that can work in the first inequality, or it can work in the second inequality, or it can work in both. Okay, when I use the word and, okay, the solution has to work in both inequalities. But when I use the word or, it only has to work in one inequality. So it looks like the answer choice here is going to be A. And this is why. If I pick a solution that's greater than 1, say 1.5, if I pick 1.5, it's going to work here, but it's not going to work here. If I pick a solution 4, right, 4 is greater than 1, it's not going to work here, but it is going to work there. And let's say that I pick the solution 0, it's not going to work here, and it's not going to work here. So the solution here is x is greater than 1, because I have solutions that will work in one inequality or both inequalities. Okay, we have reached the end of this video. In this video, I hope that you learned how to solve inequalities, and that inequalities are used to find the minimum or maximum amount. And I hope you learned about compound inequalities, the and, or inequalities. And I also hope that you learned whenever you are solving an inequality, if you multiply or divide both sides by a negative, reverse the direction of the inequality. That's the end of this video. Good luck with your assignment. Bye.